Good morning, brothers and sisters, ladies and gentlemen, young people. I'm extremely pleased to be here with you. This is a very important event. I think this is an event which not only represents how academies of science can work together for capacity building, but also to bring people together from different Muslim countries and to forge partnership for future development. In brief discussion with different friends, after the inauguration, we have already discussed possibilities of bringing people, young scholars to Pakistan and organizing more events. So it's certainly an extremely important one. Now, see, speakers during the inauguration ceremony has already mentioned about the importance of spectroscopy. Spectroscopy is our eye to microscopic world, and spectroscopy help in understanding the event at atomic level, molecular level, tissue level, and at larger level, even as cosmo level also, because we now understand the elemental analysis of different planets based on the spectrum which is generated. And my job here is only to introduce you to what is going to come in next 2 days. There is going to be whole range of presentation broadly in two categories. There would be some friends who would be introducing techniques. So you would hear a lot of lectures about mass spectrometry, LCMS. You would hear lectures about GCMS, UVIR. You would hear lecture about biological NMR spectroscopy. But then you would have many presentations in which colleagues would be presenting the applications of those techniques. So you have a blend of technique, understanding the concept of techniques, and then on top of it, the understanding the application and appreciation of the importance of those techniques. And I'm sure these 2 exciting days would actually bring together lots of very important information which we may often miss. Now, realizing the fact that there are lots of senior people also, and there are some young scholars too, my presentation would largely be a blend of basic concept and also to some level the application of spectroscopy. Based on the topic of this workshop, I would be focusing largely on the application of NMR spectroscopy in the field of food and industry. And this presentation of mine would continue tomorrow as well, and my colleague, Professor Titre will talk about that in both her presentation and also workshop session. So I would recommend, if you have time and if you can quickly get the snapshot of this slide, these are some of the books which we have recently contributed on NMR spectroscopy. They are among the top books and published by US publishers, and they speak about the concept of NMR spectroscopy. NMR spectroscopy is one of the most robust techniques. It is nuclear magnetic resonance spectroscopy, and these books are available. The soft copy is available. If you want to buy hard copy, is also not so expensive. But if you would like to get copy of that book from us, gratis, we would be happy to contribute. Then we are publishing for an international publisher a top-class series of book on the application of NMR spectroscopy in different fields. You will soon realize that NMR is everywhere. Sure, sure. Can you kindly close the curtains. Okay, so NMR is everywhere. NMR is used in industries, NMR used in agrochemical, NMR used in quantitative laboratories, forensic laboratories. NMR is even used for biomedical application. So NMR is one technique which is finding applications in almost every field of science. And this book series, about 12 volumes of this book series, each volume is focusing on one particular aspect of it. So there is a very good NMR volume on food science, the application of NMR spectroscopy on food science. The reason why I'm telling you, because many of these books are also freely available without any cost. Now, I don't want to create an impression as if it is an undergraduate class, but for the sake of completion, it is my responsibility to just introduce what spectroscopy is. Spectroscopy in the modern world is the eye of a scientist to see what is going on inside the substance, whether it is the structure of a molecule, the behavior of an atom, composition of a mixture, or dynamics of a molecule. How molecule behaves in a small little tiny world of atom is deciphered by using spectroscopy. And spectroscopy, there's so many of spectroscopic techniques available. So literally everything, when long time ago, when the spectroscopy techniques were start development, in the time of Niels Bohr and others, they used different kinds of electromagnetic radiations. Different electromagnetic radiations have different frequencies, different wavelength, and different energies. And they are capable of manifesting different changes in the substance. So some of them can knock out an electron, and that knocking out of electron would eventually lead to X-ray scattering. Some of them can just only have bonding stretching, so it could be UV, IR. Some of them can have electronic transition, that is UV visible. Some of them can have different kinds of nuclear spin jump, and they are all spectroscopic technique. I just want to tell you extremely curious thing. During the development of spectroscopy technique, these techniques were developed long time ago, X-ray, UV, infrared, microwave. These techniques were developed long time ago. It is a fundamental principle of physics that when you irradiate, when you provide electromagnetic radiation on the substrate, there is going to be certain changes in substrate, and as a result of it, you would have some empirical result, radiative energy which come out of a sample. This was an extremely curious wavelength. Radio wave, you give radio wave to the substrate, nothing comes out of it. You give UV to your sample, you see UV coming out of it. You give IR, infrared to your substance, you get IR transmitted. You give X-ray, you get X-ray scattering. But when you give radio frequency to the sample, nothing comes out of it. And this was one of the holy grail of NMR spectroscopy. For a long period of time, the spectroscopists were wondering what happened when radio wave is provided to a sample, where it goes, why there is no result out of the radiation of radio wave. And that is exactly, it took almost 70 years to develop NMR spectroscopy. NMR spectroscopy is one of the last techniques in spectroscopy developed, and it was developed only in 1940s and 50s. Well after 50 years after X-ray, 75 years after UV, 90 years after IR. So there's lots of development, and this was even accidental. So this is the kind of equipment. you know, no matter how fancy an equipment is looking like, today you go to any laboratory and you find these beautiful black boxes. You know, you see lots of lights coming out of it, many screens and other, but essentially all spectroscopic equipments are just these three. You have a source of electromagnetic radiation, you have a sample, and then when these radiation interact with your sample, substance, food, biochemical, tissue, medicinal plant extract, environmental pollutant, whatever you have, and these radiations are either scattered, emitted, absorbed, and you get this difference in analyzer. Everything else is just a recording devices. This is exactly what you need to have. These three components are the most important architect of a spectroscopic technique. This is exactly what physicists were trying to do. When they were trying to irradiate, they assembled this equipment, and they have, in electromagnetic radiation, they were using radio frequency. When they were using radio frequency was absorbed, radio frequency was given to the sample, nothing was coming out of it, nothing. And now there was a basic fundamental understanding which physicists missed for a long period of time. They didn't really realize a very simple concept. Of course, they were very smart people. They know that the absorption of radio frequency takes place when there are two states of energy. When there is a low